Good day. It's Tuesday, June the 1st. I'm Martin Gago with Market Radius Research. Today we're joined by Kiril Mugerman, CEO of Geomega. Geomega is a clean tech company developing and commercializing extraction and separation technology for rare earth and critical metals to be used in recycling and metals processing. Kiril, thanks for making the time for us, and let's hear your pitch.
Excellent. Thank you, Martin. Thanks for having me here. So today we'll be talking about Geomega and giving you an update on recycling and clean processing technologies, especially with our most recent news, where our technology is being used now not only for recycling rare earths from magnets, but as well to process bauxite residues, and of course to explain what else we are trying to do with our technology in other mining and industrial sources. So forward-looking statement, being a public company. So in terms of clean technologies, we really focus on a few aspects, and we are expanding more and more. I suspect between now and the end of the year, you'll see more items appear on this front page. But our main front project is rare earth recycling from magnets, and that would be the first rare earth recycling facility outside of Asia. It's fully funded, ongoing detailed engineering in preparation to procurement and construction. Beside that, we have the Montviel rare earth deposit, which is the largest rare earth bastnäsite resource estimate in North America, with a patented metallurgical process for it, with all the infrastructure that you would want. And as I mentioned, most recently, the Bauxite Residue sustainable processing technology. And that is really exciting for us because finally, we are able to demonstrate that our technology can be applied to more than just one material. So bauxite residues, and we'll talk about the potential there and what does it mean for us working with a major industrial partner and getting rare earths, scandium, and other metals out of this. And the final one is the lab from where all those new technologies come out. A strong technical team led by our Chief Technology Officer, Dr. Puya Hajiani. And we are really working on leveraging the rare earth expertise that we developed and the expertise in some of those technologies that we've developed with iron and iron extraction, acid recycling, and those give us a huge opportunity in penetrating several mining primary feeds, mining waste, and industrial waste and e-waste opportunities. So we are constantly looking at other opportunities, other materials, and this just keeps giving us more growth potential for our shareholders moving forward. So a bit of a history starting from 2011, where when Montviel was discovered here in Quebec. By 2015, we were able to delineate the largest 4311 bastnäsite resource estimate in North America. We've been developing since 2013 our proprietary technologies for rare earth extraction and rare earth separation. By 2015, we've patented the first innovative technology using low acid and low power for Montviel. Since then, we really focused on technologies more and more. We created a subsidiary called Inord that is focused really on developing those technologies, and Geomega's job is commercializing them, as you mentioned, Martin, in the beginning. So in 2017, we managed to do the first demonstration of extracting and purifying neodymium, dysprosium, cobalt from neodymium iron boron scrap at lab scale. By 2019, we managed to get to the first pilot and initial supply agreements with various partners. In 2020, engineering with Hatch, and the second pilot, a 50-liter pilot. Since then, in 2020, we managed to expand, as I mentioned, to other feeds, and we want to keep expanding those opportunities and to see what's out there. And in 2021, just recently, that first announcement of developing the technology for bauxite residues processing. A quick overview, and most of our shareholders and investors seen this. So that's an overview of our pilot plant. So the magnet material enters from the left. That material is getting processed using our proprietary technology. The focus is being environmentally safe, small footprint, and low capex. It helps de-risking the technology by being a low capex. And of course, dealing with such a high grade material like rare earth magnets, which is running at 30% rare earths, gives us a lot of flexibility from that point of view. And with us being able to recover more than 90% of the main reagents, producing no liquid effluents, a huge opportunity for us in coming from the environmental angle here and trying to produce rare earths not only using primary sources. Of course, another big opportunity for us is the iron oxide byproduct. That's very important, using traditional technologies for rare earth recycling in China. You don't recover that iron oxide, and instead it accumulates in waste. In our case, we produce iron as a byproduct that can go to various industries. And of course, we have to focus on reducing greenhouse gas emissions, which is the focus of all the companies right now. And we are a lower greenhouse gas emission process than conventional mining. So that is, you see here the facility where the demo plant in San Bruno is going to be located. So we lease one of the industrial condos, as they call them here. So one of those wings is ours, and that's where we'll be putting all the equipment, assembling the entire plant once all the detailed engineering is ready, and we are ready to start ordering all the equipment. We are fully funded for this, so we've got a $3 million debt facility from the Quebec government through Investissement Quebec. Huge support from the Quebec provincial government. They've been really instrumental in putting this together, the financing package. And beside that, $3.5 million raised in equity markets. So that's really the main core of the company. And this plant and a lot of our shareholders are looking for updates on this. That's all coming up in the near future. We'll provide the information in terms of what has been completed, what's the next stage, when are we putting all that together. So that's coming up, I would say, in the near future. Some quick summary numbers, and presented this to you and to many people. But the objective of the demo plant is starting at one shift, so 1.5 tons per 8 hours. Starting with material of 30% rare earths. That can, with a capital cost of $4.8 million, can generate target sales of $10 million. Of course, the opportunity is there going from one shift to 3 shifts. So you are going to process 4.5 tons per day. And yes, there is an additional cost for that, but by that time, you already have a cash flow coming out that will be used to finance this. Of course, with this, you can multiply everything by 3 and a targeted sales of $30 million with a profit margin of 20% plus. So very good economics, small project, easy to scale up. And once we are successful there, when I say easy to scale up, easy to replicate to more than one operation. And once we are done with that, then we can really attack the entire permanent magnet market. And here we just give some numbers, but it's all driven by electric vehicles and renewable energy. So wind power is a big consumer, and of course the electric vehicle industry that's growing more and more articles are coming every day about how many models are coming out, and it's all driven by rare earth magnets. And so we are seeing a huge opportunity because there is no way that all those magnets will be shipped back to Asia to be recycled there. So there's a huge demand to recycle. And I think we are starting at a very good opportunity where the market is not fully mature yet. We'll be up and running before all those electric vehicles are starting to hit the recycling cycle. So we'll be the well-established, well-developed, and most likely present with our technology in more than just one country. What is being recycled? Just a quick summary. You've got quite a few different opportunities, whether it's the hard drives, which are still being used, and there's a large volume of magnets in there, whether it's pumps, motors, electric motors, or the actual companies that manufacture magnets. They produce a lot of swarf and a lot of scrap, and all that needs to be recycled. Yes, China is the largest magnet manufacturer, but Japan is a very large one. There are opportunities in quite a few other Asian countries where material needs to be recycled and cannot really be shipped to China. So companies are always looking for clean, sustainable opportunities to recycle rare earth magnets. Just a quick summary of the circular economy cycle that is very important for the end users. and for those large manufacturing companies. So rare earths coming from primary ore then go through a metal manufacturing where some waste gets produced. Then a lot of waste gets produced during the actual magnet manufacturing stage. That is the largest chunk, the swarf. That goes towards the final product where it gets either assembled into very small assemblies or large assemblies such as wind turbines. Of course, all those items, they go for a certain amount of years before they hit the bin, and that there are more and more companies who are now being established in collecting it, sorting it, separating it, and once it's all sorted, and that traditional recycling industry is very active in learning and evolving with the new demand of metals. So those magnets, once they're collected, they need to go through a chemical processing, which is basically what we offer instead of a solid. You cannot really just take magnets and cut them and reshape them and start using them again. So that's the advantage of our technology. And the growth of the opportunity is just unbelievable. And all the numbers that you're seeing here are still based on rare earth pricing from 2019, before the 2020. So before the December 2020 price increase that started as we saw the markets re-emerging from the COVID shutdowns and the big demand that started coming out, and there was a lack of supply of rare earths. So all those price increases, we've seen rare earths increase at least 2 times since then. So all those numbers can be multiplied if you really want to see what is the potential. And we wanted to make sure that our technology functions at the low rare earth price environment. And so that is the example that you see here. But you can significantly expect growth from there, especially as you're taking several portions of the rare earth recycling market. So I'll jump here towards our recent addition to our portfolio, bauxite residues. A quick overview of what bauxite residues are. It's produced as a waste or as a byproduct from producing treating bauxite to produce aluminum. There are over 80 plants worldwide, and they all have to produce. There are different estimates. It's between 1.4 to 2.5 tons of bauxite residues per 1 ton of aluminum. So the numbers are actually quite big, and the aluminum industry is massive by itself. So with 4 billion tons of bauxite residues already stored and 150 million tons of bauxite residues being produced every year, we are seeing a very big opportunity there. And this market attracted us specifically because of some of the components that are in there. And one of them is iron and rare earths. So if you look at the value distribution, you're looking at between $80 and $120 of metal value lost per ton of bauxite residues. That material is not being recovered today. $400 billion just in sitting in storage facilities. And that is a huge opportunity for Geomega and for our shareholders. If you're looking at just the annual production of what new material is coming out, you're looking at $15 billion of value. Now, where is that value sitting? How is it being distributed? You're looking at iron between 40 and 50%, alumina around 25%. Those are 2 big sectors, big markets, and you don't have to reinvent or create those industries. Those industries are there, so the buyer is there. Beside that, of course, in your composition, you have scandium and rare earths, titanium and silica, calcium and sodium. Now, in terms of the value is all sitting in iron, aluminum, rare earths, and scandium. After that, the balance 25% is in titanium and vanadium. So you can see that the material, although it's an extremely complex material, the main constituents of it are very basic, 3, 4, maximum 5, and that's what you have to bring value to. So the average plant globally would produce around 2 million tons. You're looking at around $200 million in metal value. And of course, for us, the objective is to develop it through, to deploy the technology through licensing and royalty agreements with the worldwide aluminum industry. So we are quite excited about that. We were able to demonstrate that we can recover 80%, over 80% of the metal value in there. and that 80% is a huge volume reduction. So iron, aluminum, as soon as they start coming out, you're already hitting around the 60-70%. So very excited because that industry requires needs help. It's right now producing too much waste, and that waste is not positive towards what we want this planet to be in the future. So by us working with iron and alumina, we are able to recover those bulk metals and maximize the volume reduction. By recycling the main reagents, as I mentioned to you earlier, that's one of the things that the key parameters that we developed with rare earth recycling. We are able to reduce costs on effluents. By doing that, we are able to then go after the scandium, rare earths, titanium, and vanadium, which are valuable minor metals concentrates. And even though they don't really reduce the volume significantly, but they do bring a lot of the revenue. And of course, to develop sustainable scandium supply is something very interesting for the automotive, aerospace, and a few other very strategic industries. And finally, the idea of everything what we are doing in Geomega, it's to make environmentally safe technologies, to reduce water consumption, to increase acid and reagents recycling, reduce effluents, help promote technologies that can remove potential soil contamination or water contamination. So we are very happy with what we've managed to develop until now. There's still a lot of work ahead of us. We now started working with a major industrial international partner. We're very excited about that because many companies tried before to work on bauxite residues, and we have a very different approach from the traditional university research groups. We managed to combine quite a few technologies that we put together in the past for Montviel process or for the magnet recycling process. And we have all those synergies between various steps that we are putting together. And we managed to demonstrate it. And we have now a very good partner that we can work with, advance it to a pilot stage. Once it's to the pilot stage, then of course we can put all together the economics. We've already demonstrated internal positive economics evaluation, but at the pilot scale, we'll be able to put numbers that we'll be able to present to the market, and what does it represent, and what does it represent as potential royalties and licenses for Geomega and its shareholders. So by using reagents which are non-corrosive, it of course helps us by reducing the high cost specialized equipment. And we are avoiding all those specialty sophisticated purification steps. And that helps us reduce CapEx and to de-risk scale up. So very positive in terms of what we have here in front of us. And our critical metals R&D group is continuing strong. My colleague Puya is very excited with the many different projects that we have in front of us right now. And we are looking at the best opportunities, and Puya has really good, interesting ideas how to attack them and how to solve those environmental problems. And we are really excited to be making a difference on this world. So really, focus is always reduction of iron, recovery of critical materials and rare earths, and materials where there is a lot of reagents that are being consumed. We want to attack those. So quite often, those are the main projects that we want to be looking at. Montviel, of course, everybody is familiar with our project. A lot of value is sitting in the ground there. Very well located, support from the government. We got already a technology that we patented, and we are always improving and modifying that just to make the project even more, even stronger in the current low price environment. Because everything that we have done in the last 5 years has been done with Montviel in mind. So for us, the technology the objective is to demonstrate using the technology that the project Montviel is robust even at low rare earth prices. And that's thanks to recyclability of main reagents, reduction of environmental footprint, simplified process, and iron as a byproduct. So all those things together, with the technology being so much more mature than it was in 2015, the market demand is so much stronger and much more real, if I can call it that way, than it was 5-10 years ago. We're very excited for the potential of Montviel as well. Just a quick summary of the management team. And in summary, look, Geomega is focusing on clean processing technologies for critical and strategic metals. That's what we do, and we want to demonstrate it through low capex and low opex rare earth recycling. Start generating our cash flow. Now we are expanding to bauxite residues, again using the same core of the technology, the same principles, and with a significant major rare earth project here in Quebec or in Montviel. We think the future is very bright. We've got several of those R&D projects ongoing, and we are happy to try other materials as more companies reach out to us and ask if we can help them. And it's all going to be not necessarily at a high cost to our shareholder, because we're looking to apply quite a few of those technologies through royalties and licenses, which reduces the risks of capital raises for our company of dilution. So it's very positive, the approach that we've selected here to develop those technologies. Just a quick little overview of our share structure: 126 million shares, well financed to complete all our ongoing projects, and quite excited for the coming 12 months. Thank you very much, Mark.
All right. Kiril, thank you very much for the presentation. And now we're going to move on to part two, the Q&A, or the deep dive. So thank you very much.